This video lesson demonstrates how to divide by fractions. It's important to understand that fraction division is talking about dividing by a fraction and not that your dividend or your first number is a fraction. Because if you can divide a fraction by a whole number, and that is dividing by a whole number, whereas fraction division means that you are dividing by a fraction. What's important in this lesson is understanding that your given number, your dividend, is never going to change. It's what you're starting with. Nothing happens to it. What can happen and what you can do is you can rewrite the second number or the divisor in other ways. So that's what fraction division is all about, and that is what this video lesson is going to demonstrate. This lesson is going to demonstrate and explain the algorithm for dividing by a fraction. It's very important that you write down anything in red or anything else that you're instructed to in your notes section and any blue vocabulary words in your 3-column vocabulary section. Please be sure to ask any questions you may have as you go through this video lesson. The purpose of this lesson is for you to be able to articulate, which means state, and explain the connection between dividing and multiplying fractions. Also to divide a whole number by a fraction, to divide a fraction by a whole number, to divide a fraction by another fraction, to convert fractions and whole numbers to their reciprocals and back, and to solve real-world problems using fraction division. Please use your Go Math or Springboard workbooks to define these terms in your 3-column vocabulary section if you have not already done so. If you already have these terms in there, you do not need to write them again, but you want to make sure that you have them in your semester 1 vocabulary section somewhere. Fraction, denominator, numerator, improper fraction, mixed number, inverse operations, multiplicative inverse, proper fraction, reciprocal, simplify. This is where we are headed with the algorithm or the rule for dividing by fractions. If you are dividing by a fraction, here are the 7 steps to follow. Step 1 is to rewrite any whole numbers as improper fractions. Step 2 is to rewrite any mixed numbers as improper fractions. Step 3 is to rewrite the first fraction, so on the next line, rewrite the first fraction. Step 4 is to write the multiplication x. So that x stands for multiplication. You can also use a dot, that would be just fine, but that is step 4. Step 5 is to write the reciprocal of the second fraction. Step 6 is to multiply the first fraction by the second. And step 7 is to simplify your answer. So what is a fraction? You should have defined this in your vocabulary section. But a fraction is part. It's not the whole. When we divide a whole into equal parts, we represent those parts as fractions. So this here is a whole. It is 1 out of 1. It is one whole. But then we can divide that whole into 2 pieces. Each of those pieces is 1 out of 2 pieces in the whole. We can then divide those 2 pieces into 2 more pieces, and then each piece is 1 out of the 4 pieces in the whole. And then we can divide those pieces into 2 pieces again, and we end up with each piece being 1 of the 8 total pieces in the whole. And so it's important here to understand that the denominator, the bottom number in our fraction, tells us how many equal pieces the whole has been split into. The numerator, the top number in your fraction, tells us how many of those pieces we are looking at. So if you have a fraction that says 1 over 4, 4 is the total number of pieces, equal pieces in your whole, and 1 is the number of those pieces you are going to be dealing with. We have to use fraction division because there's not just whole numbers in our lives. We have fractions and decimals, but we'll get there later. But fractions are a part of the world, the real world. And so understanding fraction division and being able to divide by fractions is necessary. In order to really understand fraction division and do it correctly, it's important that we understand fraction division as division itself. Division is division, whether you have whole numbers or not. And so there are several ways of explaining or understanding division. First, you can look at division as splitting things up. You can look at division as grouping, so making groups of. You can look at division as fitting into, so how many of these will fit into this. And you can look at division as how many. Well, how many will each whatever get? How many will each this get? So if we're looking at division as splitting things up, let's say I have 200 cookies and I want to split them up among 25 people. This is a division problem. I'm going to split my whole or divide my whole among a set number, which is 25. The result will be an equal number split, so each person will have the same exact number of cookies, and I may or may not have some left over, which, as we know, is called the remainder. If I think about division as groups of something, let's say I have 10,000 people and I need them to get into groups of 150. This is a division problem. I'm going to use division. I will divide up my whole, my 10,000 people, into groups of 150. And the result will be a whole number of groups that are all 150 people each, and I may or may not have some people left over, which again would be my remainder. If I think about division as fitting into, let's say I have a box. It's 180 inches long, and I need to fill it with smaller boxes that are only 9 inches long. This is a division problem. I want to find out how many small boxes fit into my larger box. So I'm going to divide my whole into sections that are 9 inches long to figure out the number of smaller parts that fit into the whole. The result here will be a whole number, and I may or may not have some left over. So I may only be able to fit a certain number of the boxes and end up having boxes left over, or I may actually have some space left over in my larger box. Either way, the result is a whole number and possibly some left over. If I think about division as how many, let's say I have 50 cookies and I want to know how many each of my 5 friends will get. So I have 50 cookies, I have 5 friends. If I split them up or divide them, how many will each person get? This is a division problem. I will divide my total number of cookies among my friends to see how many each one gets. This is where you can think of it like dealing cards. You deal like 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. And that, when I'm done, the result is a whole number, so each person has the same number of cookies, and I may or may not have some left over, which is the remainder. Division with fractions is still division. Division is division. The only difference here is that one or both of the quantities is not a whole number, but it's still division. I can still figure out how many of one quantity fits into another, or I can still figure out how many groups of something I have, or I can still figure out how many of something each person will get. I'm using fractions instead of whole numbers for at least one of my pieces. We're going to look at the example 1/2 divided by 2. It is very important that you understand the difference between dividing by 2 and dividing by a half. Dividing something in half is not the same as dividing something by a half. It's very important you understand that difference. Or saying dividing something by 3 versus dividing something by a third. So dividing something by a third is not the same thing as dividing something into thirds. Very, very important that you say exactly what the problem says, which is 1/2 divided by 2. It's not 1/2 divided by a half. It's 1/2 divided in half because we're dividing by 2. So I'm going to divide half a cake evenly between 2 people, and this is going to tell me how much of the whole cake each person received. This is example 1, this particular problem, so you want to make sure you write that this is example 1 and you write the problem 1/2 divided by 2. As I go through this problem, you may always write more than you are required. You can write anything you see or even make your own notes, that's totally fine, but please make sure you at least write what is in red or what you are instructed to copy. So here's the setup. We have cake for a party. The day of the party, half the cake gets eaten, which means you have half left over. The next day you have some other friends over and you want to get rid of the cake, so you want to serve it to them, but you want everyone to have the same number of pieces and you want everyone's pieces to be the same size, so we're doing equal pieces here. So here you would have to divide a fraction, which is half of the cake, by a whole number, which are the number of friends you have over. You're definitely going to want to draw these models. So I have some images that are going to be drawn. They're just rectangles, nothing fancy, but you definitely want to include this in your notes so that you can visually understand this concept. In fact, drawing pictures is always helpful when you're dividing by fractions. It's also very helpful in geometry, but we'll get there later, next semester. First, we want to have our original piece. We have the whole cake. And the first day of the party, half the cake gets eaten, so then we're left with half of the cake. So you want to have these two images on or in your notes. When half the cake is gone, you only have the leftover half to work with. So that's your leftover half. And if you have one friend over, you have to split the half into two pieces, one for you and one for your friend. So here you have taken half and you have divided that half by 2. You split that half into 2 pieces. And you want to know how much of the whole one of those pieces were. So how much did each person eat of the whole cake? So you can then look at how the smallest piece fits into the whole. So one piece here, half of the half, so one of the 2 pieces that you split the half into, is one of 4 out of the total. So we can extend that size and see that there's actually 4 of those pieces. We could have divided the entire cake into 4 of those pieces. So if I take half of the half, that's equal to 1/4 of the whole. Therefore, 1/2 divided by 2 is 1/4 of the whole. You should have defined reciprocal in your vocabulary section. Reciprocals are essential for fraction division of fractions. Reciprocals are 2 numbers whose product is 1. When you multiply them together, your product is 1. This is an example of a reciprocal, 2/3 and 3/2. 2/3 and 3/2 are reciprocals because when you multiply them together, you get 6/6, and 6/6 is 1. 1/2 and 2/1 are also reciprocals. This is because when you multiply 1/2 times 2/1, you get 2/2, and that is equal to 1. Side note here, if you don't remember how to multiply fractions, or if you really just feel like you need a refresher course in other fraction operations, adding, subtracting, multiplying fractions, please let me know. I have lots and lots of resources for you to use to make sure that you are really confident with adding, subtracting, and multiplying fractions. The key here with reciprocals is that the fraction bar represents division. So when I say 1/2, what I really mean is 1 divided by 2. So 1 piece divided into 2 slices. Let's look at a new example now. Again, you're going to want to draw the models. The example is 1/2 divided by 3 instead of 1/2 divided by 2. So there's another party. At this party, half the cake gets served and there's still half left over. But the next day, 2 people come. Not just 1, but 2 people come. So I divide the half that's left over into 3 equal pieces, 1 for me and 1 for my 2 friends. So how much of the whole cake does each person get? What is one of those 3 pieces from the half? So here's the whole cake that we started with, and there's the half that's left over after the party. Then my 3 friends come over, so I cut that half into 3 pieces. So I want to know what one of those pieces is in terms of the whole. One of the three pieces from this half, what is that in terms of the whole? Well, if I extend those size pieces to the other part of the original cake, I have 6 of those size pieces. So one of those 3 pieces of the half is the same as 1 of the 6ths of the total cake. So 1/3 of the half is the same as 1/6 of the whole. Let's talk about translating this into mathematical terms, which we call the algebraic translation. So here I took a half and divided it by 3. So I divided it into 3 pieces, or into 3 groups. Each person received 1 of the 3 of those pieces, so 1/3 of that half. So I did 1/2 divided by 3, and I know that that's 1/6 of the total. So 1/2 divided by 3, one of those new pieces is 1/6 of the total, of the whole cake. So I did 1/3 of the half, which is 1/6 of the whole. Important thing to do here is to write the whole number as a fraction. We want all of our numbers in our equations to be in the same form. And this will be important later. If you have a fraction and a decimal in the same equation, you want to convert them so that they're in the same form, either both fractions or both decimals. So here we have an issue with one of the numbers is a fraction and one is a whole number. So we want them to be the same form. Well, we can't convert a fraction into a whole number because by that definition of a fraction, it's not a whole number. But we can write a whole number as a fraction simply by putting the whole number over the number 1. Because since the fraction bar represents division, 3/1 is the same thing as 3 divided by 1. And 3 divided by 1 is 3. So when we have 1/2 divided by 3, that's the same thing as saying 1/2 divided by 3/1. And it's very important to understand what each number represents here. This half is of the total cake. So this half is this big piece here. The 3 is how many pieces that original half gets split into. And the 1 is how many of those 3 pieces we are looking at in terms of the whole. And this will become extremely important later. Let's take a look at another example. Here we have 2/3 divided by 8/3. Well, you'll notice here that there are no 1s. There's no whole numbers, there's no 1s, so this is going to be a slightly different type of problem. It's the same mathematical problem. We're still dividing by a fraction, but it's going to be conceptually a little different. So let's say the next party, instead of half the cake being left over, I have 2/3 of the cake left over. So I don't know, people weren't hungry, maybe it wasn't a very good cake, I'm not really sure, but I have 2/3 of the cake left over. The next day, I have 8 friends over, and I don't want any cake. So I'm going to cut the leftover 2/3 of the cake into 8 equal pieces. Then I try and give it away, but 3 of my friends say, nope, no cake for me. So now I've only served 5 of the 8 pieces of the 2/3. Suppose I should have asked before I went and cut the cake, but I didn't. So I have 8 pieces of the 2/3, but I only end up serving 5 of them. I want to know how much of the original cake still hasn't been eaten. Well, I had 8 equal pieces of the 2/3. I'm left with 3 of those 8. So I need to know what 3 of the 8 pieces of the 2/3 are in terms of the whole cake, the original cake. So here you're going to want to draw these models. This is what this problem looks like visually. So the 3 of the 8 pieces that didn't get eaten of the 2/3 in terms of the whole cake. So we have my cake. This is the whole cake. Beautiful sheet cake, maybe from Costco, Publix, I don't know. 2/3 of the cake does not get eaten. So there's my remaining 2/3 of the cake. 8 people come over, so I divide those 2/3 into 8 equal pieces. But 3 of them don't take those pieces, so I still have 3 of the 8 pieces from the 2/3 of the leftover cake. Well, then if I extend those size pieces, I find that that makes 6 of 24 equal pieces in my whole cake. And of course, it's very important when you're talking about fractions that we're talking about equal size pieces. Let's talk about this in terms of mathematical or algebraic terms. I took 2/3 of the cake and I divided those 2/3, or I split those 2/3 into 8 pieces or 8 sections. So I did 2/3 divided by 8. But I didn't want to know what just one of those pieces represented in terms of the whole cake. I didn't want 8 over 1. I didn't want to turn that whole number into a fraction. Instead, I needed to figure out what 3 of those 8 pieces were in terms of the whole. So I actually wanted 8/3. And this is extremely important here, that just like before, this 2/3 is my starting amount. The 8 is the number of pieces I split my starting amount into. And my denominator here is the number of pieces I compare, the number of those pieces, the number of the 8 pieces, I compare to the whole. So what those numbers stand for is absolutely vital to understanding fraction division. So now I know that 2/3 divided by 8, and then looking at 3 of those pieces, so 2/3 divided by 8/3 is 6 out of 24. And again, here's that diagram, the visual model that shows that. Let's talk about a pattern. In the first problem, 1/2 divided by 2. This, and I'm going to write this in black, but I would encourage you to write this down. It's not in red because it won't stand out really from the numbers, but I had 1/2 divided by 2. 1/2 was my original amount. I'm going to use AMT for amount, just to save space. 2 was the number of pieces or slices I made from the original amount. Then when I wrote this, that's still this. This 2 is still here. But then when I wrote this whole number as a fraction, that 1 is how many of the 2 slices I compared to the whole. So here I was only looking at 1 of the 2 slices that I made out of the original half, and that was 1/4 of the whole. Same thing with 1/2 divided by 3. The 1/2, again, is my original amount. The 3 is the number of pieces or slices I split the original into, and that is this 3 as well. And then this 1 is the number of pieces of the 3 I compare to the whole. So if I take 1 of the 3 pieces that I made from the 1/2, that's actually 1/6 of the entire whole. And then with the 2/3, my last example, 2/3 was the starting, or my original amount. This 8 was the number of pieces or sections or whatever you want to call it. I split my original amount into, and this 3 was the number of pieces of the 8 I compared to the whole. And 3 of those 8 pieces that I made from the leftover 2/3 is the same as 6 of 24 pieces of the whole. So it's 6/24 of the whole. So there's a pattern. If you look here, this 2 matches up with this 4. These 2 1s match up with this 1. This 2 and the 3 matches up with the 6. The 1s match up with the 1. The 8 and the 3 match up with the 24. The 2 and the 3 match up with the 6. What is this pattern? The pattern is that the answer to my division problem is the dividend, which is the first fraction, multiplied by the reciprocal of the divisor, which is the second fraction. So this is where multiplication and division are so related, because they're inverse operations. Multiplication and division are inverse operations. So if I am multiplying by the reciprocal, I'm doing the inverse of division, which is multiplication, and I'm doing the inverse of the fraction, which is the reciprocal. So I'm using inverse operations to divide by fractions. Let's take this a step further. Let's use reciprocals and our understanding of multiplication to divide a fraction by a fraction. I know that 1/2 divided by 2 is the same as 1/2 divided by 2 over 1, because I can turn a whole number, I can rewrite a whole number as a fraction by placing it over 1. I also know that that means I split my half into 2 pieces, and I'm comparing one of those 2 new pieces to my original whole. When I divide a half by 2, what I'm really saying is how much of the whole 1/2 of the half is, because I split that half into 2 pieces. So what's half of the half? Well, the word of, that's an operations word. Of means to multiply, represent multiplication. Therefore, I can rewrite 1/2 divided by 2, which, as with the whole number as a fraction, is 1/2 divided by 2 over 1. I can rewrite that as 1/2 times 1/2, and that gives me 1/4. Again, you'll notice that I have done the inverse. The inverse of divide is multiply. The inverse of 2 over 1 is 1 over 2. That's the reciprocal. So I've used inverse operations and inverse fractions to divide by a fraction. So does this work for the other ones? Let's check. In example 2, we still had half the cake, so we split half of the cake into 3 pieces. And we looked at how much of the whole one of the 3 new pieces of that half was. Of means to multiply. Therefore, 1/2 divided by 3, so divided into 3 pieces, I can rewrite that as 1/2 divided by 3 over 1. So I'm looking at one of those 3 pieces, which really means I'm doing 1/3 of 1/2. So 1/2 times 1/3. And that gives me 1/6. Again, here is the inverse. Inverse operation, inverse fraction. The inverse of divide is multiply. The inverse of 3 over 1 is its reciprocal, 1 over 3. In example 3, we split 2/3 of the cake, the remaining 2/3 of the cake, into 8 pieces, and determine how much of the whole 3 of those 8 new pieces of the 2/3 was. Of means multiply. Therefore, we were finding 3/8 of the 2/3. So 2/3 divided by 8, so divided into 8 pieces, and then looking at 3 of those pieces, so 8/3, is the same thing as 2/3 times 3/8. We're finding 3/8 of the 2/3, and that gives us 6/24. So again, inverse. I can do inverse operations, and I get the same thing. Dividing by 8/3 is the same thing as multiplying by 3/8. These examples have demonstrated a pattern, and this pattern is what we will call the algorithm or the algebraic rule. Dividing by a fraction is the same thing as multiplying by its reciprocal. That is a phrase that you must memorize. You must learn it, you must know it, it must be part of your being. You must know that dividing by a fraction is the same thing as multiplying by its reciprocal. We can then use that pattern and that rule to write the algorithm, the rule for dividing a fraction by another fraction. And that rule or algorithm is any fraction a over b, and the a can represent any whole number, any whole number at all, a over b divided by any fraction c over d, where c and d are numbers, so these letters a, b, c, and d, which by the way, we call them variables. These just represent any number you can think of, any whole number that you can think of. So a over b divided by c over d, those two fractions, is the same thing as, it's equivalent to the fraction a over b times the reciprocal of c over d. So a over b times d over c. And so anytime you have division by a fraction, this is the rule you're going to follow. This is the algorithm. And you end up with the product of the numerators, so a times d, over the product of the denominators, b times c. You'll notice again this inverse. The inverse operation for division is multiplication. The inverse of the fraction cd is the fraction dc. That's the reciprocal. What if we have mixed numbers as part of the problem? That's fine. All you have to do is convert the mixed number to an improper fraction. Just like when we have whole numbers. What if we have whole numbers as part of the problem? Well, you just rewrite that whole number as an improper fraction. So same thing with mixed numbers. Regardless of whether your mixed number is your dividend, which is your first number, or your divisor, which is your second number, you just convert that mixed number to an improper fraction, and then you go on your merry way and evaluate the problem. If you don't remember how to convert a mixed number to a fraction, then you can certainly make sure you have this in your notes so that you can follow these steps. You multiply the denominator of the fraction by the whole number, then you add the numerator and write the sum over the original denominator. So here we have an example, 3 and 2/5. So here's our mixed number, 3 wholes and 2/5. So I multiply the denominator by the whole number, so 5 times 3, or 3 times 5. Then I add the numerator plus 2. So 3 times 5 is 15, plus 2 is 17. And I write that over the original denominator, which is 5. So 3 and 2/5 becomes 17 over 5. Now let's take what we've learned and model a typical fraction division problem. The first fraction that we are given in a fraction division problem is the amount of the whole that we are going to be working with. It is our starting amount. So the first number, our dividend in our fraction, that is not a very straight line, is 5/8. So first I need to draw my whole. And I'm going to be splitting this whole into 8 pieces because the bottom of our first fraction, the bottom of a fraction tells us how many pieces that we have divided the whole into. So there's 4, and now I'm splitting those 4 in half. And I have 8 pieces now. Well, I'm only interested in 5 of those pieces because the top number of my first fraction tells me how much of the whole, how many of those 8 pieces, which is 5. So I'm really only interested in these 5 pieces here. I'm not interested in the rest of them. And I'm actually going to change colors here just to give you a better idea of a visual. So this second fraction, I'm going to use blue. If you have a blue pen or a blue colored pencil, you're welcome to color code this as well, but you don't have to. You can draw it in just your regular pencil. That's just fine. This second fraction is where we have to look at the division as fitting into or how many or how much. The top number of our divisor tells us the number of pieces we are going to split our original amount into. So our original amount is 5/8 of the whole. So I'm going to split this amount into 3 pieces. So here is 1, and I'm going to continue this way because we have to figure out compared to the whole. And now I have 3 pieces. I've split those 5/8 into 3 pieces. The denominator of our divisor tells me the number of pieces of the numerator size I'm going to compare to the whole. So I'm going to be comparing four pieces of this size. Well, one of these pieces has 1, 2, 3, 4, 5 small pieces. The original whole was split into 8ths. That's what the original 8 splits were. When I split those 8ths into 3 new pieces, that gave me the whole in a different size piece. So it went from 8 pieces creating the whole to 24 pieces because now there are 8 pieces this way, but 3 pieces this way. So I have a new number of pieces making up the whole. I have 24 pieces now making up the whole. So in one of my 3 pieces, I have 5. So then this would be 2 pieces would have 10 of the new small size, and 3 pieces would have 15 of the small size. But if I look back up at my divisor, the denominator says I need 4 pieces of that size. Well, I don't have 4 pieces of that size. I only have 3. So what I need to do is I need to create a what if. If I had another one this size, how many of those new small pieces would I have? Well, that would be another 5 small pieces, so I would have 20. So if I take 5/8 and I divide it into 3 pieces, and I look at 4 of those pieces compared to the whole, I have 20 of the new small size pieces, 20 of the 24. Another way to look at that is to say, instead of saying I want to imagine this row, is to say, look, one of these pieces has 5 of the new small pieces. So I have 5, 10, 15. A 4th piece would have 5 more pieces. So I would use this, and this. That would be 5 more pieces. So this would make 20. So I can use that in another way of looking at where those 5 pieces are coming from, because the 5 pieces are there. They're just not in the same size as the 3 pieces. They don't go all the way across like this. They're put together in a slightly different format. But that is what fraction division is. If you model fraction division, it's looking at taking an amount of original whole, splitting or dividing that amount of the whole into a certain amount of pieces, and then taking a look at a certain number of those size pieces and comparing it to the original whole. We can do one more problem like this. So let's look at problem 2, modeling the fraction division. And let's say I have 2/3 divided by 5/6. So 2/3 is my dividend. And that's going to be how much of my whole I'm going to work with. So I'm going to split my whole into thirds. So now I have 3 pieces making up the whole. That's where this 3 comes from. That tells me how many pieces to split my whole into. And the 2 tells me how many I'm going to be looking at or working with, my original amount. The 5 here tells me how many pieces I'm going to split the 2/3 into. So I'm going to have 1, 2, 3, 4 lines, and that creates 5 pieces. You'll notice now there's 5 this way on the width, and now there are still 3 in the length. So my original whole, which I had split into 3 pieces, now it takes 15 smaller pieces to make up the whole. The denominator of my divisor tells me the number of pieces of this size that I'm going to look at. I need 6 of them. Well, one of them has 2, so this is 1, 2, so this would be 4, 6, 8, 10. I don't have a 6th one, that's 5 of them, so I need to imagine a 6th one, which would be 2 more pieces, so 12. Or again, you could say, look, there's 2 extra pieces, so this would be 11, and this would be 12. Either way, you're using 2 more pieces because that's how many 15ths are in one of the 5ths of the 2/3. So then I say, look, I've had 2, 4, 6, 8, 10, 12 of the 15 pieces. And if you use the algorithm, that is equivalent to our starting amount, our 2/3 of the whole, times, which is the inverse of divide, the reciprocal, which is the inverse of our divisor, 6/5. So when we do our fraction multiplication, 6 times 2 is 12, and 5 times 3 is 15. And so this proves the algorithm for fraction division. Please make sure you ask any questions that you have.